Hi everyone, you're watching video note 611. Getting to the near end of the unit here. 611, we're going to solve some equations. We've been doing this for a few days now. Linear versus quadratic. Linear we haven't seen since, I don't know, like unit 3. So we're going to make some comparisons and see if you remember how to solve linear equations. Solving equations in algebra, linear equations, again, back to unit 3, has variables that are only to the first power. If you remember, mx plus b, you're looking at a 1 power on that. And so you'll never see an x squared, and solving it will be different than all the methods we've been doing in this unit. You're going to try to get the variable alone, and we're going to use a method I like to call sorting, also inverse operations. You'll remember this when we see some examples also. Well, I can do it actually. Let's just do an easy one here. 2x plus 3 equals 7. This is what we're talking about. Get x alone, subtract 3. We're sorting the numbers over to the other side. So you might just thought I'm moving that over and making it the opposite sign. 2x equals 4. Now the opposite of multiplying, I'm using the inverse operation, divide by 2. X equals 2. Very simple linear equation. Quadratics have an x squared. So you might also see another x in the equation with it. The key to solving a quadratic is looking for zeros. That was new this unit, looking for zeros. Unless you can solve using inverse operations, you should set the equation equal to 0. So you're always going to be looking to pick the best method. Will you use factoring, completing the square, the quadratic formula, or inverse operations? Think of this as like your bag of tricks. Whenever you see a square, those have to come to mind. If it tells you what method is specified, if it tells you what to use, then you have to use what they say or you'll only get half credit. In example 1, so what is this? Is this linear or quadratic? It's quadratic. I see an x squared. Well, actually, I see a y squared. So it's a quadratic. What method are we going to use to solve it? Well, I see two y's in there. I see a y squared and another y. And that tells me I don't want to use inverse operations just yet. I can't easily get y alone if there's a y squared and a y. So I'm not going to use inverse ops. So I'm either going to use factoring or the quadratic formula. And you really can't go wrong with either. But if it's easy to factor, you should probably use factoring. So I'm going to subtract my 24, get my 0, my big fat 0 on the right-hand side. And this does factor easy because I can see the numbers happening. Y and y, that makes my y squared. 24, I thought of 8 and 3 right away. You know, there's 2 and there's 12, there's 1 and there's 24. But 8 and 3 because it sounds like a 5, and I knew the signs were going to be different. I want the 5 to be positive, so I'm going to use a positive 8 and a negative 3. Again, if you're not real good at factoring, you can still go like this and put in your y squared and your negative 24 and talk about the numbers that need to be in here. You can also use a graph and look for the zeros. Anyways, let's get these answers. Y plus 8 equals 0. Subtract 8. This is a little linear equation I'm solving here. Negative 8. Remember that when you have a quadratic, there's usually two solutions. Example 2. This one's linear. Do you know why? Think for a minute, see if you know why. If you said it's because there's only an x to the first power, I don't see any x squares. That's why. What method will you use to solve them? Let's use sorting, where we get all the x's on one side and numbers on the other side of the equal sign. And why are we doing that? Because we want to get x alone. So here we go. Well, in order to get there, you can't have these parentheses. So I'm going to distribute the 2, which means multiply that in. 8x minus 6. And then I'm going to look at my x's, and they're on opposite sides. I'm going to try to get them together. So I'm going to keep this 8x here, but I'm going to subtract the 2x over next to it. Trying to keep my equals lined up. I'm going to keep this 4 and the minus 5 over there. I could actually combine them if I wanted to, but I'm going to add the 13 and the 6. And now I can combine them all. So over here, I end up with a 6x. And over here, -1 and 13 is 12, plus 6 more is 18. Finally, inverse that. Opposite of multiplying is divide. And x is 3. And you should check by plugging that back in and make sure it works. So on your next page, oh, what did I just do? Yep, that was the same page we started with. Okay, never mind. On the next page, example 3, when it says solve for x, I look at the equation. I notice an x squared, so I'm saying it's quadratic. And what method are we going to use to solve? I don't really know yet, although it says nearest hundredth. I'm thinking because of the keyword that I'm going to be rounding, that I'm going to use my calculator to help me get to those decimal numbers, that I should probably use the quadratic formula. They're not going to be nice numbers like when you factor. So let's get 2x squared plus 5x minus 8 equal to 0. Again, there was an x squared and an x, so I can't use inverse operations. Not using inverse ops unless there's only an x squared. So a is 2, b is 5, c is -8, x equals -5 plus or minus the square root of b squared is 25 minus 4 times 2 times -8 all over 2 times 2. Quadratic formula. Get what's under the radical. That would be 25 minus 4 times 2 times -8. 4 times 2 times -8. Enter. 89. That's not a perfect square. 89 is still under the radical. It said nearest hundredth, so I'm allowed to go to my calculator. So -5 plus the square root of 89 is all going to be on the top of the fraction. -5 plus the square root of 89. And oops, I got to get rid of that a and s there. What the heck is that? And on the bottom of the fraction is going to be my 4, or I could have just put 2 times 2, but I know that is a 4. 3.60849. 3.60849 dot dot dot, an irrational number. So I put the dot 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 to the nearest hundredth. That's right there, and the 8 makes that go up. 3.61. I got to go back because there was a plus or minus. I got to go back, highlight that, hit enter, and change the plus to a minus. -1.10849, -1.10849, dot, 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 to the nearest hundredth spot is -1.11. The 8 made the 0 go up. And finally, example 4, solve for x. Leave your answer in simplest radical form. It's a quadratic. I see the x squared. Ooh, I like this one. There's no other x. So I'm going to use inverse operations. It's just x squared. That's easy to get it alone. If there's an x in there, I can't. But if there's nothing else, all I'm going to do is add 65 over to the other side. So normally I would have thought x squared minus 65, bring the 10 over. I would have done that. And I still would have then thought, okay, I'll move the 75 over there and take a square root. So basically, I have x squared equals 75. And my x squared is alone. I can take a square root and put a plus or minus. Simplest radical form means I need to simplify the radical. So perfect square factor hiding out in 20 or in 75 is a 25 times 3. It's a 5 when I take the square root. 5 radical 3. You could say 5 radical 3 and negative 5 radical 3 are your two answers. And that's it. Just keep all those little hints in mind, because sometimes you use one method and sometimes you use another method.